just means you haven't taken that Regents exam yet. You're probably wondering where this has been. If you haven't been wondering where this has been, whatever. I'm drinking some Dunkin' Donuts coffee in my RPI mug. Dunkin' Donuts is not a sponsor, although I wish I had one. It always makes me do math better. Not really. I make mistakes no matter what. All right, so if you're here for the January 2019 Algebra 2 Regents exam, you have come to the right place. We are going to be doing part 1, problems 13 through 24. Now, during this exam, I, Mr. Krause, otherwise known as Mr. Answer Key, I'm going to be going through how to solve. By the way, if you're not here for this exam, well, what the heck are you doing here, first of all? But if you're not here for this exam, then, you know, and you want the other part, you want the first ones, go to mrkrause.math.com, go to Algebra 2 Review, scroll down, and we hit Common Core Regents, and then you scroll down to the bottom, and now these should be live links. By the time you get here, these should be live links, okay? They're not right now, but they will be very soon, okay? All right, let's get rid of that. But I'm going to be showing you how to use the calculator to get the right answer, how to choose the calculator to check your answer, how to solve the problems the right way, and how to get around problems that are a little funky. And I'm going to show you some tricks, some traps, and things to improve your score. Here's what I want you to remember, and you got to remember this. Got to. Yeah, that's cool stuff. 1, I'm a little nuts, so this is going to be a little crazy. I'm also a little bit hyped up on some caffeine, so it's going to be even crazier. But here's what you really need to remember. This test is not hard to pass. I know you're freaking out right now. You don't remember everything. There's tons of stuff. Somewhere on my website, there's flashcards. Do I show you how to get the flashcards? I wonder if I have to do that. Review material. I have flashcards somewhere. I don't know. Maybe I'll put it up there. It'll be up there sometime. Regents Review. Maybe that's it. I don't know, somewhere there. I got flashcards. There's 262 flashcards on Study Blue. Look for MrKrauseMath.com or Mr. Krause Math on Study Blue app from Hilton High School. You'll be able to get my flashcards. But anyway, it's not that bad. You can do this, okay? Here's all the stuff I've already done. We're not gonna do that. We're gonna start over here on 13. All right. So question 13. If you want the others, go back to my website and pick up the other videos. You can also subscribe to the YouTube channel. That way you'll know when I update, when I redo videos and all that stuff. It's coming soon. All right, here we go. This function, f of x, is equal to a, which stands for amplitude, how high up it goes, how far down it goes. B is our frequency, number of curves in 2 pi. And C, this is our midline. How far up the whole graph shifted. We always start with the midline. I'm not even going to look at the answer right now, but I'm going to start from the midline because putting in that midline is ginormously huge. So I see the top is 5. I see the bottom is 1. I notice the difference here is 4. So I'm going to go 2 up. And this is where the midline goes. Choice 3. So I know C is equal to 3. Already right there, I'm down to 2 choices. Gone and gone. Now, from there, I'm going to go up 2 or down 2, up 2 and down 2. That makes A equal to 2. A is 2, B, A is 4. Boom. So this appears to be the right answer. By the way, I'm going to show you some freaking crazy cool stuff, okay, how to do this problem. So it looks like B is equal to 3, the number of full curves in 2 pi. Wow, that's really weird. No, it says B is 6. 2 pi over 3. That's freaking weird. So what this says is we're going to finish 6 curves in 2 pi. Well, I see 2 curves, but I'm not even close to 2 pi. 2 pi is down here somewhere. So what I want to do is I want to check to make sure that answer is right. So do you see this piece of graph paper right here? This is one of the tricks that you can use on your computer or on your test to see that you get the right answer. You see this piece of graph paper? We're going to recreate that piece of graph paper exactly. So come over to the old graphing calculator. Get rid of all this crap. We're going to go into graphing mode. Make sure you're in radian mode. If you're not in radian mode, you got to be in radian mode. And again, we're going to create this graph exactly. So let's see. It goes from 0 to 5, 6, 7. So this top number should be 7, which is close, but we're going to make it exact, 7. Now this right number, I'm just going to go to 2 pi over 3. So that means I'll end right here at top. So I'm going to end right here. So 2 pi over 3. So 2, come over here to the old pi button, pi divided by 3. And then I'm going to press tab again. And this is negative 1, 2, 3. So negative 3. I'm going to press tab again. Now this is the tricky one. But if you'll notice, if this is pi over 6, then this would be half of it, which would really be pi over 12. But you know what? If I just go negative pi over 6, I think we're going to be in pretty good shape. You'll see. Because I don't really care about most of it. I'm going to make it look almost exactly. Negative pi divided by 6. All right, so that's this piece of graph paper almost exactly. So here's what we're going to do. We're going to press tab, and I'm going to type in what they said was the answer. They said the answer was A, which is 2, cosine bx, so 6x, and then plus 3. Now, we're not going to look at this part over here. We're only going to start looking right here. Do you see 1 full curve and 2 full curves in 2 pi? Does it look like it moved up 3? Yeah. Do you see how you get the same number of curves? As long as you set up your graph paper on your graphing calculator to match exactly what's shown in the picture, you'll be able to see, oh yeah, it looks exactly like that. I know I got the right answer. All right, moving on. All right, so I'm going to show you the right way to do this problem and then the wrong way to do the problem. And so all of these are in what's called vertex form. So I'm going to go through and write the vertex next to every one of them. The vertex here is negative 3, negative 5. If you don't remember this, see if you can figure out how I'm getting these. The vertex here is positive 3, positive 5. The vertex here is negative 3, positive 5. And the vertex here is positive 3, positive 5. Now, so what we're going to do is this. We're going to come here. I'm going to show you the right way, and then I'm going to show you the wrong way. Our directrix is y equals 7. So that's y equals 7. So 1, 2, 3, 4, 5, 6, 7. My vertex, well, hold on. My directrix is negative 3, 3. 1, 2, 3. This is my focus. Focus. Now, you need to remember, this is the right way to do this, you need to remember that the vertex is somewhere in the middle of those two. Well, that looks like negative 3, 5. Would you all agree that negative 3, 5 would be in the middle of those two? Yes. So that means we are probably at, well, looks like this is the right answer. Negative, positive 3, 5, positive 3, 5, negative 3, 5, negative 3, negative 5. So there's the right answer. But I'm not going to rest there. I want to use my graphing calculator as a tool to make sure that is in fact correct. Now, I thought it was going to come down to these two. I didn't notice that this one was different than this one. But let's say this was a positive. Nope, then you can't do that. Let's say this one over here was a positive. So that means that negative 3, negative 5. So then it was like, okay, now we're down to these two. Well, why is it this one and not this one? And that's because of this thing out here front. Remember, when it's negative out front, that means it's a parabola that's opening down. Okay. Now, I know it's choice 3, but I want to use my graphing calculator as a tool. No, you're not a tool. Okay, some of you are tools, but not all of you. As a tool to get the right answer. So control division, negative 1 over 8, parenthesis, x plus 3 squared, and then plus 5. I think that's what it was, right? Yes. So do you see how this graphed it for me? Nice here for me? So what I'm going to do here is I'm going to go Menu, Analyze, and Analyze. And I want to check out the focus. And I click on it. Oh, look, focus is negative 3, 3. Focus is negative 3, 3. Now I'm going to go Menu, Analyze, Analyze, and we're going to do directrix. Oh, look, the directrix is y equals 7. I could have just done it that way. So the problem is choice 3. Bam, there's the answer. Now I'll move on. All right, so I'm going to show you how to do this problem the right way and then the wrong way. But the wrong way gets you the right answer all the time. The right way, don't make any mistakes. So we're going to do the right way. If this was a part 2 question, part 2, here's how you would do it if it's a part 2. First thing you're going to do is take care of the badass minus. This bad old minus. We're going to make this a minus, we're going to make this a plus. Or that's a plus and that a minus. Next thing we're going to do is put parentheses around anything that's added and subtracted. Now, I always annoy my kids and I say, okay, what's the lowest common denominator? And they say x. Oh, because I see an x there and this thing's got an x, so that's an x. No. This thing is 3x plus 1. This thing is just x. So my lowest common denominator, x, times 3x plus 1. So, if I put an x here, I'm going to put all the missing stuff in. If I put an x here, don't I have to put an x in here? This one's missing a 3x plus 1, so I'm going to put a 3x plus 1 here. And this one is missing an x. All right, so here's what I got. I got 2x over x times 3x plus 1 plus, oops, excuse me, that's an equal sign, equals 3x plus 1 over, because I just distributed the 1, over x times 3x plus 1 plus negative 6x squared over 3x plus 1. All right, so now I don't need these. So let's see what I have. I have 2x equals 3x plus 1 minus 6x squared. Now you see how this 6x squared is negative? That's a problem, which means you need to bring it over to the other side. You can't have a negative x squared. So we're going to bring everything over. So when I bring that over to the left, I get 6x squared. When I bring this 3x over, I'm going to minus this. I'm going to subtract this over, minus x. And I'm going to bring this 1 over. I'm going to subtract 1. So I get minus 1 equals goose egg. I'm assuming it's going to be 3x and 2x. But I might go to my calculator and just do menu 331. So calculator, menu, algebra, polytool, solve a polynomial. Change this to complex always. 6, negative 1, negative 1. So 6, negative 1, negative 1. And there we go, negative 1/3. So those are my answers, equals negative 1/3. So this is plus 1. And x equals negative 1/2. And this is plus 1. So these are my answers. Now, therefore, that's the right answer. Whoa, that's not the right answer. Oh, wait, one of these has to be negative. One of these has to be positive. See how it's negative 1/3? But this was positive 1/2. So that means this is negative. All right, so negative 1/3 and positive 1/2. There's the right answer. Yes, I'm done. Don't go ahead. I don't think that's the correct answer. And why is that not the correct answer? Because all rational equations must be checked for extraneous solutions, bogus answers, answers that make the original fraction undefined. Now, some of you that are really, really smart already know which numbers make this undefined. I will answer that question in a few minutes. I'm going to show you how to do this calculator, do this problem with no work. See, all that work, and that's not the right answer, so we're going to get rid of it. I don't think it's the right answer. And here's what we're going to do. We're going to go to our calculator, and we're going to take these answers, and we're going to store them in. So my first answer I'm going to store in is 1/2. So control division, 1/2, 1/2, and we're going to store that into x. enter. And then I'm going to type in the original problem. And you only have to type this in once. Don't type it in more than once. 2 over 3x plus 1. Don't use the equal sign. There it is, 4/5. And then I'm going to do control division again. 1 over x minus, that minus is awful. That minus is really awful. Negative 6, oops, excuse me, just 6. 6 over 3x plus 1. Oops, didn't write it in right. 1 over x minus 6x. Ah, you got to type it in right. I forgot the x. 6x over 3x plus 1. So that's the right side. Let me just remind you, this is the left side. Notice they're both 4/5. So I know 1/2 works. So 1/2 has to be one of my answers. So really all I got to do is check to see if this negative 1/3 works. You're going to find out it doesn't. So watch what we're going to do. I'm going to go up here. So this should now be negative 1/3. And I'm going to store that into x. I'm going to type in the left side, or the right side. And I'm going to type in the left side. And they do not equal each other, do they? Oh, crap. This should be negative 1/3. I'm not sure how this didn't get changed to 1/3. I was expecting something else to happen. There's negative 1/3. Sorry about that. I'm going to type in the left side. Now, here's what you should see. Undefined. And here's what every doggone kid does, and it drives me up a wall. Undefined does not equal undefined. Undefined means, sorry, that's not an answer. Undefined does not mean, or does not equal undefined. I can't say it enough. Undefined does not equal undefined. No, it means it crashed. And the reason it crashed is because if you type in negative 1/3, this turns out to be 0. Now, there were some smart people that said, oh, wait, I know that x can't be negative 1/3. The other answer x can't be is 0. So anything with a negative 1/3 had to go. So here's my suggestion to you all. Just check the answers. Plug them in, see which ones work. All right, let's go to 2 or 16. Savannah got some contact lenses. Her doctor said she can wear them 2 hours for the first day and increase the length of time by 30 minutes each day. If this pattern continues, which formula could... Oh, wait. Stop the press here. Not be appropriate. That means 3 of these are okay. Determine the length of either minutes or hours. All right, so we're going to do it in minutes and hours. So let's go. We'll go hours first because that was what was given to us. And then we'll also do this in minutes. So we said she can wear them for 2 hours. So 2 hours or 120 minutes. And she can increase that length of time by 30 minutes a day. So increase by a half. Increase by 30 here. Do you see what the difference is? They tried to trick you there. So these two are done recursively. So I'm going to grab my calculator and show you the cool way to do recursion. Now let me do it the lame way first. A equals 120. A sub 1. A sub 2 equals... Now remember, this thing right here, that represents before. Your teachers might call it before. It represents the term before. So in this case, the term before is 120. And we're going to add 30. That's 150. Oh, wouldn't that be 30? Wouldn't that be 30 more? And then, so 30 more would be 120 starting. 30 more would be 150. 30 more would be 180. 30 more would be 210. So that's what we need to get here. For this one, we need to see 2, 2.5, 3, 3.5. We got to figure out which one's not going to give us this. All right. So A3 would be equal to the term before, which is 150, plus 30, and you get 180. And I think you see that that one is, in fact, going to work. Now we're going to do hourly. So hourly is this one. We're going to start with 2, and we're going to take the previous term, which is 2, and we're going to add 0.5. Well, that's 2.5. Then we're going to take the previous term, which is 2.5, and we're going to add 0.5. That's 3. And you see this one works. So now we got to figure out what the heck's going on here. So N. So A sub 1. Now A sub 1 should be 120. So I'm going to do 90 plus 30 times 1. That's 120. A sub 2 should be 150. So A sub 2 is equal to 90 plus 30 times 2. So it's 90 plus 60. That's 150. And I think you're going to see that this is going to work. Here's the one that doesn't work. If I took A sub 1 and I go, okay, it's 2.5 plus 0.5 times 1, that's equal to 3. That means A sub 1 is equal to 3. No, it's not. I did say I was going to show you something cool about recursion, about these two up here. And if you haven't seen this before, it's actually kind of cool. You come over to the old calculator and you type in the first term. So you go, okay, 120. Enter. Just put it in. And then you hit plus. Now you see how it says answer plus? Answer plus 30. That's what this one says. Take the previous answer and add 30. Now once you do that, 130, 150, 180, 210, it'll give you the recursion. Now let's do it with the hours. So I take 2, store it in. And now I'm going to put plus, oops, that's times, plus 0.5. 2.5, 3, 3.5, 4. And that's what this one would do. All right, so the answer is 4, choice 4. Inverses. All right, let's talk about inverses. We're going to do this the right way, and then we're going to do it the wrong way. Now, the right way is a joke. Really, really, really fast. I'm going to write it as y equals a to the x. Now, to find the inverse, your first step is to switch x and y. So we're going to say x equals a to the y. Now, this is an exponential equation. Okay, this is an exponential equation or function. In order to solve an exponential function, I have to do its inverse, which is logs, which is why all the answers say logs. So we're going to write log. Now, if you've ever heard Meghan Trainor's song, or you heard me sing it, it's all about that base, about that base, about that base, about that base. Yes, I told you I was crazy. About that base. Well, let's look. This is the base. So if that's the base, that is the exponent. And logarithms are all about that base. So log base a. Now logarithms are equal to exponents. Y is equal to x. And that is the right answer, which is choice. Well, of course, we don't want to write, we will write it as f inverse of x. So instead of writing y equals, we write f inverse is equal to log base a of x. You want to make sure you circle the right one. I can't tell you how many kids' tests go back and they'll come by and I got that one right. No, you didn't. Look, you picked the wrong choice. Don't pick the wrong choice. So that's how to do it algebraically. Very, very quick. Now let me show you how to do this graphically. You have to remember that inverses are reflections over this line y equals x. So if they're inverses, whatever they are, they got to be inverse, or they got to be symmetric, or they got to be reflections over that line. So let me type in the original one, a. I got to make up a number for a. A is bigger than 1. So I'm going to say, I'm just going to make up a number. Press tab. I'm going to put 2.33 raised to the x. Now remember, a is going to be 2.33. Okay, there it is. So now I'm going to press tab, and I'm going to do control log. Now the base over here was a. So remember, that was 2.33 of x. Now, these should be reflections over that line. Do they look like reflections? They sure do. Did I have to do this algebraically? I sure didn't. I could have graphed them and also graphed that line y equals x and just see, yeah, they're reflections over the line y equals x. All right, kiddos, we'll come back. Let's see if I think I need to take a little quick break. Oh, here we go. Oh, here we go. I hate these questions. I'm going to guess most New York State teachers hate these questions, unless you like really, really love math. I love to teach. Not necessarily love math. I mean, I like math. Don't get me wrong. I mean, it's not my life. But I love to teach. And this question, every year they ask this question, and every year it gets crazier. Crazy. All right, let's see if we can figure this out. Maybe this isn't quite. Yeah, this is. Kellyanne has 20 G's to invest. Woohoo! Wish I had 20 G's to invest. She puts half of it, that's 10,000. Compounded monthly. Oh, this isn't actually that as bad as I thought it was. Nope, this isn't as bad as I thought it was. At the same time, she puts the other half of the money in an account that grows continuously. We got to talk about that at a rate of 0.08. Actually, I don't mind this question. This question's not bad. I was thinking it was a different one. So, compounded monthly. This is asking 2 questions in one. So whoever wrote this question is like, you know what? I can get 2 questions in one right away. And compounded continuously. Anytime you see continuously, that's E, which is why you see all of these with E in it. So they were kind of nice to you to let you know, oh, it's going to have E in it, because they all have E in it. So we're going to take the compounded monthly, because I believe that's going to be the harder one. You're going to start with $10,000. And we're going to increase by 8% annually. This is an annual interest rate of, 0.9%. So that's going to be 1 plus 0.09 to the t. Now, if I just did that, that would be an annual growth. This is not an annual growth. We have to convert this to monthly. So in order to convert it to monthly, I have to convert this to a monthly rate, divide by 12. Oh, I already made a mistake. Do you see how this is 0.9% and I changed it to 0.09? That was dumb. This is 0.009 divided by 12. But when you do it monthly, you got to divide by 12, divide by 12. If this was quarterly, you divide by 4, divide by 4. The continuous part just is it's the easy part. 10,000 e to the point, again, 008 t. See how I converted it to decimal? Now, if you're not good at that, you can always come over to your calculator and go like this. 0.08 divided by 100 and go, okay. Man, why is it doing that? Why can't it just give it to me in regular? I'm sure there's, so anyway, all right. You got to know, I guess. All right, so I know that it's got to be, can't be this one, and it can't be this one. And this one's just got 0.009. It doesn't have the 0.009 divided by 12. So there, in fact, is the correct answer. And if you put this into your calculator, I'm not going to do it, but that'll give you that answer right there. All right. Which graph represents a polynomial function that contains this? Oh my God. This is a ridiculously cool question. Love this question, although it is very, very difficult. So here's what I'm going to show you. If this is a factor, then it should give you roots. So what I'm going to do is I'm going to factor this thing. And if you factor it, believe it or not, you get x plus 1 times x plus 1. Or in other words, you get x plus 1 squared. Well, if that's true, then the root should be x equals negative 1. Well, how many of these have answers at x equals negative 1? Negative 1, negative 1, negative 1, and negative 1. So 3 of them are very similar. 1 of them is quite a bit different. Do you know which one's different? Choice 1. And that's because, do you see how it's squared here? Your teacher should have taught you that if you have a squared, that really means you have a bounce point. In other words, you're going to come up, you're going to bounce off, and you get down. And that's a bounce point right there. And because that's a double root, it should bounce off the x-axis at negative 1. Great question. I actually love that question. Tough one, though. All right, here we go. We're moving on. Sodium, trigonometric conditions, have a half-life of that. The data below shows the amount of... No. What approximate amount of sodium will remain in 18 hours? What? Okay, so I'm going to do this 2 different ways. I'm going to go do the regression equation on this one. It's clearly exponential, right? It's a half-life, so it has to be an exponential equation somehow. So let's go through and let's just go do this using our calculator. I'm going to show you a couple of different ways to do this. X, Y. I'm going to look down. I apologize in a second. 1, 2, 3, 4, 5. 139, 69.5. I'm going to show you another way to do this problem. I should probably get 69.5. 34.750. 17.375. And 8.688. 8.688. Bam. Okay. So, I'm going to go... like this. I'm going to say, okay, menu. Well, maybe you don't know it's exponential growth, and maybe what you need to do is go into Doc, Insert, Data and Statistics, click on X, click on Y, and see that, oh yeah, this is exponential growth, decay. See how it's got a base of 1/2? All right, so if you go back over here and you do menu, analyze statistics, stat calculations, and exponential regression, click X and click Y, this should give you a base of 1/2. Do you see how the base is 1/2? So my A value is 277.933. So here's my equation. Y equals 277.993, 1/2 to the X. All right, no problem. Let's see. Yeah, I'm just going to plug in 18 now. So 277.993 parenthesis 0.5 parenthesis raised to the 18. 18th half-life. 0.001. That appears to be the right answer, except for I must have something wrong. Sorry. Sorry, I screwed up. I forgot about this. This represents the number of half-lives. 18 is the number of hours. I almost screwed up and picked that first choice. Boy, that was a tricky one. But 18 hours divided by 1.8 hours gives us 10 half-lives. 10 half-lives. So I don't want to put in 18. I want to put in 10. And that gives me my 0.271 whatever. All right, so that's one. God bless it. That's one way to do it. Now, the other way to do it is not to do this at all. Notice this is going down by a half, going down by a half, going down by a half, going down by the half, and it's, of course it is. So, the only thing I have to do then is take 18 hours and divide it by 1.8 to figure out how many half-lives is that? Oh, it's 10. Oh, and then I just go, okay, I'm going to take 8.688, enter, and then hit divide by 2. So this would be the 6th half-life, 7th half-life, 8th half-life, 9th half-life, 10th half-life, 0.271. There it is. Tough question. Kind of a cool question, though. Whoever wrote that one, kudos to you. That was a 100-buster right there. Great question. Loved it. All right. Which expressions are equivalent to this? So again, this would be one where you just store a number in for x, type this in, and type all these in. As a matter of fact, that's the only way I do this question, because this problem's awful. But let me show you how it's done mathematically. In the numerator, we're going to take out an x. Remember, you got a factor. See how that's got minus? Put it in parentheses. So I take out an x. I'm left with x minus 4 all over 2x. All right, so if I just cancel this x out with this one, I know x minus 4 over 2 is an answer. So anything that doesn't have 2 in it's got to go. Oh, look, they all have 2 in it. So what I have right here is x minus 4 over 2. Now, let me ask you this question. What's 3 over 8 plus 5? Nope. 4 over 8. Well, wouldn't you agree that's 7 over 8 or 3 plus 7 over 8? See how I can go backwards with this? So what I'm going to do is say this is equivalent to x over 2 minus 4 over 2. Well, isn't this really just negative 2? So negative 2 plus x over 2. 1 works. Now we just got to see if 3 works. Now here's the way you're going to do 3. See how they already have a common denominator? Why in the world we would do this, I don't know. But I can add them, and I can say, okay, that's x minus 1 minus 3 is minus 4. And that one works as well. So that's why that's the right answer. Now let me show you how you do this on the day of the test. Well, I don't know what the heck I'm doing here. I'm going to show you how you do this on the day of the Regents. Check this one out. Let's red X. I got too much crap stored in there. Go. And I'm going to take 2.567887. I'm going to store this into X. Press enter. And then I'll do control division. X squared minus 4x all over 2x. Shabam, I get that number. Then I'm going to do x divided by 2. X divided by 2 minus 2. I get that same number. Then I'm going to do control division. X minus 4 over 2. I get that same number. Then I'm going to do control division. X minus 1 over 2 minus 3 divided by 2. Oops, wasn't 3 divided by 2. X minus 1 over 2. And I get that same thing. See how I was able to get all the same decimal? There you go. That's why it's the answer. All right. We're almost done. 3 left. Consider this function defined by this graph below. Something's wrong. Consider f of x. Oh, consider f of x. Okay, so this is f of x. And this is p of x. All right. The difference between the values of the maximum of p and the minimum of f is. Now, here's what I want to warn you about. There's only 2 times you use y values. Range and min-max. So the max here is the y value, which is 5. And they wanted the maximum of p. Now what we got to do is graph this sucker and find the minimum. So we'll go over to our graphing calculator, and we will graph this thing. So it's 4x squared, 4x squared, plus 6x, and then minus 3. I got to find the minimum of this. All right, so I'll go here, menu, analyze, minimum, click, click. The minimum is negative 5.25. So the minimum, so the max is 5, and the min is negative 5.25. Now you have to be careful. I bet 0.25 is an answer. Of course it is. It said, what is the difference between the max and the min? Difference means subtraction. So that's 5 minus negative 5.25. How many all fell for that one? This is plus, and the answer is 10.25. Wow. Wow, that's tough. Be careful. Not tough. You just got to be conscientious. Alrighty. This one's not too bad, although I think I did it wrong the first time I did this video, so I'm reshooting it so we get it right. We are normally distributed, so as soon as I see normal distribution, I'm going to do this. I did like most other people did. I read the question wrong. We got a mean of 68. And this one was a little bit tricky because they said we have a standard deviation of 7.2. Now, if you read the question carefully, you'll find out that anyone that's scoring higher than 1 standard deviation will not be enrolled in mathematics. How many of the 750 will be enrolled in it? So, if I add 1 standard deviation, I get 75.2. And so that's 68 plus 7.2, which is 75.2. So at any rate, so what's going on here is you want to find out how many of these 750 kids don't score over 1 standard deviation. In other words, I want to find out what percentage of the kids are down in here. So this is a relatively straightforward question. You grab your old calculator and you do menu, and then it's statistic, it's probability, distributions, and normal CDF. Now the left bound, according to our graph, the left bound is way down here at negative infinity. So my calculator says negative infinity. Whatever yours has in it is probably negative infinity. The upper bound is going to be 75.2. The standard deviation is 68. And the mean is 76. 68, and the standard deviation is 7.2. So we just click OK. And we get 84.1%. Now that should really come as no surprise. 8.841344, right? You know that this is 50%, and you probably learned that this is 34.1%. So about 81%. But again, I want how many of these kids. So I got to multiply this times 750. And we get 631. So there's the answer to that one, 631 peeps. Okay, kid, that's the answer. And then this last one we got to do. This one's a little bit tricky. The only thing they want to do is know how many solutions, not what the solutions are, how many solutions. So what we got to do is just set these two things equal each other in the graphing world. So red X, don't save. Go into the graphing world. We go control division 1 over 1 minus x squared. X squared. Press enter. We get some weird looking rational expression or rational function. And then we hit the tab button. We get the negative. Absolute values are found underneath the key of everything right here next to the 9, right here in the second row. And I believe it's 3x something. 3x minus 2. And then on the outside, plus 5. Now remember, we only want to know when they are equal to each other. In other words, when do they hit each other? So we just press enter. So let's see. We see an answer here. 1, 2, 3, and 4. So there are 4 choices. And that's it, kids. That's the end of January 2019, Part 2, numbers what do you got? 13 through 24. Please hit the subscribe button, hit the like button. Again, if you need to go, you need to find all of the Regents exams are found at www.mrkrausemath.com. When the Regents is done this June, on June 21st this year, I will do the videos, I'll shoot them, but New York State restricts when I can upload them. So as soon as I can upload them, I will. But keep working hard. Good luck. Remember, it's not difficult to pass this thing. Use your calculator effectively. Use your tools. Use all the tricks I've taught you. And then do your best. All right, good luck, kids. Catch y'all on the flip side. Goodbye. No, really, goodbye. No, you got to go. Goodbye. Go. Okay, bye. Good luck. No, really. Okay. Goodbye!